All right. As you might have remembered or not remembered, I'm downstairs I'm not here. So here's a video over our next section 4.2, and we're going to start off with a little rapid fire for the Pythagorean double angle trig identities. So go ahead and get out a piece of paper. Don't write out the whole word. Just sit there and try to figure out, if you can, what the identity is. Whether it's a Pythagorean or a half angle. Or a double angle, sorry. So, yes, I moved my chair around. Some kid was in here. All right, so here we go. Mark. There we go. All right. So let's see how many you got right. There you go. Check them off. You should have got at least half of them right. If you haven't learned it by now, you need to practice, practice, practice. So, anyway, let's see. The mean value theorem is what we're going to talk about today. You got to turn the knob. There you go. Mean value theorem. Remember, mean means average. So we're going to be finding averages for the mean value theorem. So in your notes, draw a function on a closed interval a to b such that the two y values are the same. And f of x is differentiable on ab, means it's continuous, and it has no sharp points or asymptotes. I got a sub. So draw a picture, and the y value should be the same. You can have a straight line, a hump, it doesn't matter. So this is known as Rolle's theorem. He noticed that when you did something like, you don't have to write down Rolle in this theorem and stuff like this. He found out that when you did something like this, here's my picture, that there's a point between a and b that's a critical value where the derivative equals 0. And that's known as Rolle's theorem. If there is two y values the same, there's a vertex. At the vertex, the derivative has a value of 0, and that point, x value, is known as a critical value. You have to have at least one. So we're going to take this little theorem and apply it to the mean value theorem. All right, got that written down? All right, it's time to move on. I don't have all day. I got 14 more slides to do, and I can't wait on you. So here we go. Let f of x be 4x squared minus 20x plus 29. Does this satisfy the hypothesis of Rolle's theorem? In other words, does the function value of 1 equal the function value of 4? If so, then is there a place where it's equal to 0? Well, of course, there's going to be a vertex that's a quadratic. So the derivative is 8x minus 20. You end up with 5 halves as the critical value. See you later. So that's critical value. Is that between 1 and 4? Yes, it is. So now we're going to sketch the graph. All right? I got the derivative. I got the critical value. Now I'm going to sketch the graph. So the function value of 1 and 4 is both 13. The critical number is 5 halves. So everything looks like it's going just fine. And there's a horizontal line. That would be the tangent line. Okay? That's it. You just show the y values are the same. You find the number between the x values. That gives you the derivative equaling 0. If you have more than 1, you pick the one between the interval 1 to 4. Okay? That's Rolle's theorem, not the mean value theorem. Okay? This is Rolle's theorem. We're going to use it in the mean value theorem. Here we go. All right? The only difference between Rolle's theorem and the mean value theorem, there's two of them. One, the y values are not the same. Okay? And two, you're not looking to where the derivative equals 0. Take a look at something about Rolle's theorem. If I connect the endpoints from A to B, what is the slope of this line? Yes, it equals 0. So this is where the average rate of change, I'm using a mouse, I'm trying my best. The average rate of change equals the instantaneous rate of change. This is the instantaneous, okay? Instantaneous. Instantaneous, you get the idea, okay? The instantaneous rate of change equals the average rate of change. All right? That's the mean value theorem. All right, time to move on. So, we're going to draw another picture, f of A, f of B. The average rate of change is the slope of the line connecting them. You draw another picture, and you end up with that, okay? You don't need all those words, you'll be fine. You don't know what they mean anyway, and I'll explain them to you. So, here you have the A's not equal to the B, okay? It's a continuous function, so there's no place where there's any asymptotes, any holes in the graph, any steps. It's all good, it's all smooth. So, what the mean value theorem says, here you can find the average rate of change again. Okay, now this you need to write down and we'll talk about. So I'll give you a minute. I'll be right back. Okay, so the mean value theorem, it says if a function is continuous, then there must be at least one C between A and B such that the instantaneous rate of change is equal to the average rate of change. Okay? The instantaneous must equal the average rate of change. That's true. The instantaneous rate of change is the derivative value of C. The average rate of change is the slope of the line connecting the two endpoints. Okay? That's the slope of the line containing the two endpoints. So, with that said, I'm going to show you another way it's written in your homework. That way you're not all confused. If I multiply the denominator over, I end up with this. F prime of C times B minus A equals F of B minus F of A. Do you see how those are the same thing? Okay? I just multiplied it over so it takes one line instead of taking two lines. All right? But the mean value theorem, the mean means the average. So the average rate of change between two endpoints, there's a place where it's instantaneous. Okay? What's this have to do with anything? Well, if you average on a trip 72 miles per hour, that means somewhere on the trip you actually went. At some point in time, your speedometer actually hit 72 miles per hour. That's what it means. If you average something, at some point in time, your speedometer actually hit that mark. It doesn't mean it was there for the whole time. It doesn't say how many times it hit, but it hit at least once. Okay? There's a famous story where a guy got a speeding ticket. He was going from a toll booth at A to another toll booth at B. Well, the time on the ticket was calculated and found out he had averaged 72 miles an hour on his trip, so he got a speeding ticket. They couldn't say where he went 72 miles an hour. They just said he did go 72 miles an hour. He was speeding, therefore he got the ticket. All right? So that's how the average and the instantaneous work together. All right. Questions on that? Good. It's a great topic for this day of the week. Yeah, I think you'll get it. So, show that f satisfies the hypothesis of the mean value theorem on the interval from 1 to 4. In other words, is it continuous? Yes, it is. It's a polynomial. Of course it's continuous. Sketch and find a number c in the open interval 1 to 4, which means c cannot equal 1 and 4. That satisfies the conclusion of the theorem. Okay? Function is continuous. You can find two y values. You can find the slope of the line, la-da-da-da-da. Okay? First of all, if you put in 1, you get out negative 12. Put in 4, you get out 27. They aren't equal. If they were equal, that would be Rolle's theorem. But they aren't equal, so it's the mean value theorem. Do you see the difference between the two? Well, I hope so. All right, so you got the mean value theorem. You got two different y values, check. You got a conclusion that it's a polynomial, so it's continuous for all x. So therefore, there's got to be something, the derivative has to equal the average rate of change. So the derivative is 3x squared minus 8. All right, we got that taken care of. Now all we have to do is find an x between 1 and 4. So 3x squared minus 8. There's f of b minus f of a all over b minus a. Remember on your test last week, you didn't know what the average rate of change was? Now you do. So you get 27 plus 12 is 39, divided by 3 is 13. 13 and 8 is 21. So that means x equals plus or minus 7 solves the equation, but the mean value theorem says it has to be between 1 and 4. So I'm going to pick, obviously, the positive square root of 7. Okay? To sketch the graph, you just sketch the parabola or the cubic, pick your points, and you're on your way. You could have more than one c in the interval. Don't misunderstand, but it said just find the only one, so we did. But you could have more than one. It's possible. All right, so there's the square root of 7. There's the tangent line. There's f of b and f of a. Everything looks good. Okay? Sorry. Everything looks good. Continuous graph. So there is some place where the average rate of change equals the instantaneous rate of change. What is the average rate of change? Well, the average rate of change is going to be 13. The instantaneous rate of change is also going to be 13. Okay? If you put f prime of the square root of 7, 3 square root of 7 squared minus 8. 3 times 7 minus 8, 21 minus 8, that gives you 13. So that's the instantaneous, f prime of the square root of 7. And it's also the average, 27 minus negative 12 over 4 minus 1. This is the rate of change, okay? So the square root of 7 gives you where that happens at. All right? All right, good. So, this one, use the graph to estimate the numbers, plural, between 1 and 10, find the conclusion of the mean value theorem. You got to use a straight edge, okay? You got to use a straight edge to find out where this is going to happen at. So, it looks like right there is a couple places because it's parallel. You just slide your ruler up, you slide your ruler down to find out where it's going to happen. So a solid line is where my ruler started. I slid it up so it became the dotted line to see where it touched. It touches in two places, it looks like to me, 2 and 9. Now I'm going to slide the ruler down. It looks like it touches there around, I don't know, 4.5. Okay? You have to do that for homework on your own. You just take your ruler out of your planner. Well, we don't have it. Well, then use a piece of paper or something that's straight. You got skills. Figure it out. And then you slide it so it's parallel. Okay? That looks just like the pictures. There's no equation, so you're in good shape. All right. That is a continuous function. The y values don't equal each other, and there's multiple places where it's true. Okay? If they were equal, that would be the Rolle's theorem. All right, moving on. So let's check this out. Here are 3 questions. I want you actually doing these questions and see if you learned anything. Because when I'm done, you're going to have to do the homework to keep it quiet. All right? So try these on your own. I hope it works. I even checked it. Oh, and there's the mining symbol. Love it. Nice. Okay. I forgot about it. That looks awesome. All right. Is the function 1 over x differentiable over the interval -5 to 5? Differentiable means, can you take the derivative and get out any rate of change for any x value within the domain? Great. I hope you picked no. Because 0 is not even in the function. Zeros should be taken out of that interval, so it's not going to happen. It's not even a continuous function, so it's not going to be differentiable at 0. So hopefully you picked no. The next one. Does f of x equal sine of x over the interval 0 to pi over 2 satisfy the hypothesis of Rolle's theorem? Yes or no? Quiet. Let people do it on their own. Sure it does. The hypothesis says that the function's continuous, sine's continuous, and the function value of 0 equals 0, and the function value of pi over 2 equals 1. So no, it doesn't satisfy Rolle's theorem. Okay? It does satisfy the mean value theorem, though. Mean value theorem. Okay? You could put, let's see, 1 minus 0 over pi over 2 minus 0 equals the cosine of x. You could find out when, exactly where that's going to happen at. We won't do it now, but you could. So the answer to this one should be no. Oh, it says yes. No, that's wrong. It should be no. Because the function values don't equal each other. All right, so that's a typo. If f of x satisfies hypothesis Rolle's theorem, then find all the numbers C that satisfy the conclusion of the mean of the Rolle's theorem. Okay. So do this one on your own. See if it works. Okay, let's find out. I got -3 for satisfying it. Okay, do the function values equal each other? I don't know. The function value of 1 is going to be 5 minus 12 is -7, minus 2 is -9. The function value of -7 is going to be 5 plus 84 minus 98. Is it 98? Yeah, it looks like it. So 89, yeah, it looks like it equals -9 also. Okay? So the derivative is -12 minus 4x equals 0. Negative 4x equals negative 12. Oh, positive 12, sorry. So x equals negative 3. Good shape. All right, so that's Rolle's theorem. All right, moving on. 3 things. First, Rolle's theorem and the mean value theorem are close to the same. If the y values aren't equal, it's the mean value theorem. If the y values are equal, it's Rolle's theorem. They both have to have continuous functions, and both the derivatives will equal the average rate of change. In Rolle's theorem, the average rate of change equals 0. In the mean value theorem, the average rate of change equals f of b minus f of a all over b minus a. Okay? So, next, critical numbers are not the same as the c in the mean value theorem. The critical numbers are things that make the derivative equal to 0 or undefined. In the mean value theorem, the c is equal to the average rate of change, f prime of c. Don't get confused with the notation, all right? You have to understand they mean different things in different theorems, okay? So the critical numbers of a function are not the same as the c's in the mean value theorem, all right? 2 different things. And finally, the third, the functions must be continuous and defined on closed interval for Rolle's and the mean value theorem to apply. Okay? When we had the function of f of x equals 1 over x, that would not have been a candidate for the mean value theorem or Rolle's theorem if I were to cross the asymptote with the slope of a line. Okay? So it has to be continuous and it has to be defined. And it also has to occur on the closed interval. Okay? So you have a very, very important segment coming up next. I want you to work on this homework, and I want you to work quietly and get it done. Okay? The person in my place can change this assignment, and go through like 1 through 45 odd if they want. And I will not lecture on Monday. I'll do something else, okay? So if you work, this is your assignment, if you work quietly. If you don't work quietly, bump it up and let me know what I should do on Monday. If I bump it up, well, then there's no lecture on Monday, and I'll just give you a quiz over this section on the mean value theorem. Okay? So leave me a note. Let me know which assignment you gave, either assignment A or assignment B. Okay? But work quietly. Figure this out. This is a big deal. Okay? Thank you to whoever's pushed the button, and hope the rest of the class goes well. All right, I'm out of here. Well, not yet. Close.